Good morning. I'm hopeful that you all did well on your quiz on sections 1.4 and 1.5. Today we are going to look at section 1.7, which is entitled Graphical Transformations. Now, this hopefully makes a little bit of sense to you. We've been talking about functions and we've been talking about graphs. And so now we're going to talk about how manipulating a function can actually change the look of the graph of that function. All right. And so that's the whole idea behind section 1.7 here. Now, this will be, by the way, the first of two videos on this section, and it will also be the last section that we cover in chapter 1. From this point forward, we're actually going to move into true precalculus and go right to section or chapter 12. All right. Now, transformations of functions can occur in a variety of different ways, all right? But by definition, a transformation is a function that can map real numbers to real numbers, all right? In other words, for every x, there's a y, and for every x that you manipulate, there's a new y. These transformations can be rigid. In other words, the size and the shape of the graph are exactly the same. They're just drawn in a different location or possibly position on the axes. Or they can be non-rigid, which are graphs whose size and shape has been distorted. All right, they're either stretched or perhaps shrunk. All right, and so there's a lot that we can do with these transformations. There are three types of transformations: translations, reflections, and stretches and shrinks. Now, a translation is probably the easiest one to consider, because all that we're doing is you're taking the graph and you're moving it to a different position on the axis. You're not changing its shape, you're not changing its orientation, you're just moving it. All right, so you pick it up off the graph and you put it back down in a different location. That is what's known as a translation. And these translations can be up or down, left or right. It doesn't really matter, or some combination of both of those. Now, a reflection generally takes place across either the x or the y axis. All right, and so essentially what you're doing is you're flipping something vertically or horizontally. Okay, either way. All right, and so you can reflect across the y-axis, which is a horizontal reflection, or you can reflect across the x-axis, which would be a vertical translation or reflection, rather. Finally, the most complex ones that you'll deal with, in my opinion, are the stretches and shrinks, all right? Because essentially, looking at these things, you can see the whole graph is either stretched, either vertically or horizontally, or it's shrunk horizontally or vertically. Either way. And interestingly enough, for each of these three types of translations, there are very specific arithmetical operations that you do to the original functions in order to make the transformation possible. So let's start with the idea of translations. All right. A translation is the shift of a graph vertically or horizontally. Okay. So let's say that we have, come on, an axis, and well, yeah, we'll leave that one there. And so let's say we have an axis, and I'm gonna draw in blue. And here's my original function, f of x. Okay. Now, if I want to move this graph horizontally, if I subtract some number c from x, that will move my whole graph to the right. And so, for example, this would be f of x minus c. Because what I'm doing is I'm manipulating the value of x, okay? And so therefore, the value of x changes. Now, what if, on the other hand, I wanted to, I don't know what cyan is. If I wanted to move it to the left, then it would be something that looked like this. There we go. I guess that's cyan. F of x plus c. Now notice it's kind of counterintuitive in my opinion, because when you subtract c from x, you move toward the positive, but when you add c to x, you move toward the negative, all right? But that is what happens because you're actually manipulating the original value of x. Now, let's say for the sake of argument that we have again, a set of axes. I'll make this one a little bit bigger. And in this case, again, I'm going to draw in my function f of x. So the blue line represents f of x. If I wanted to move this vertically upward, I would simply add c, not to the value of x, but rather to the value of y, f of x. And so in this case, if I added c to x, I would get a line that looked like this. And so this is f of x plus c, all right? Because I'm adding c to the value of the output, the value of y. And so that moves us vertically upward. On the other hand, I guess we'll do cyan again. If I subtract c from the value f of x, that is going to lower my graph on the axes, all right? And so I can have, the moral of the story here is that I can have horizontal or vertical translations that will shift the graph either right or left or up or down, depending upon how I manipulate either x or f of x, all right? So, now, I know that this is a little bit confusing, so I want you to spend a little bit of time studying the slide that just passed through, okay? Now, for just as a general example here, all right? If you look at the graph, f of x equals x squared, all right? And in the next slide, I'm going to show you a picture of that graph. But if you take a graph of f of x equals x squared, and hopefully you remember that's a parabola, right? And if you want to shift it up 2 units, all right, well, that's a vertical translation. And so in a vertical translation, you add a number or subtract a number, but in this case, add a number to the y value, and that makes it go up, right? And so the new function in this case will be h of x equals f of x, the original function, plus 2, okay? So this is the graph of f of x, all right? So there it is, f of x equals x squared, right? And if you look at this carefully, you know it to be true, right? 1 squared is 1, right? 2 squared is 4, okay? And -1 squared is 1, and -2 squared is 4, all right? So the blue line represents the value of f of x, or the graph of f of x equals x squared. Now, if I want to move this graph upward by 2 spaces, by 2 places, all right, shift it upward by 2 units, then I have to add 2 to the y value, all right? The whole moral of the story here is that I want to I'm going to use green here. I want to move this whole thing up by 2 units, all right? But not just here. I also want to move this line up by 2 units, all right? And there we go. And if you look at this carefully, that's exactly what I've done. Everything, whoops, I missed. But everything has gone up by 2, all right? How did I do that? Well, I took my original, darn it, I took my original value of f of x and I added 2 to it. All right, now f of x, of course, is equal to x squared. And so the new function, the red line in this case, is h of x equals x squared plus 2. Notice I'm not adding the 2 to the x, I'm adding the 2 to the f of x. All right, f of x is x squared. Okay, and that's what makes it a vertical translation upward by 2. Okay, so if f of x equals x squared, then h of x equals f of x plus 2 or x squared plus 2. All right, again, this is an example of a vertical translation upward by 2 units. Okay, now let's do another example here. Example number 1 says, use the graph of f of x equals x cubed. All right, so a similar function to the one that we did in the previous slide or so. But f of x equals x cubed. And from that, I want to sketch the graph of each function. All right, now, in the first one, all right, I'm taking, I've got g of x equals x cubed minus 1. Now, am I subtracting the 1 from the value of x or from the value of f of x? If you said f of x, you are correct, right? This is really f of x minus 1. So what kind of translation is that going to be? Vertical, all right, because we're changing the value of the y, and we're going to make it go downward, because it's negative, by 1 spot, okay? In the other example, there were 2 things going on, all right? Actually, I'm going to go back to this. Here, I'm adding 2 to the cubed. And so in this case, I'm manipulating the x value. So this, by the way, this is vertical down 1. This one, I'm adding 2 to the x. And so that's going to be horizontal. And because I'm adding the 2, it's going to move left by 2. But I'm also adding 1 to the thing. So there's also going to be a vertical shift to up by 1. Okay. All right. So in the first one, I'm moving it vertically downward by 1. In the second one, I'm moving it vertically upward by 1 and to the left by 2. Now, this is the original function, f of x equals x cubed. And I'm hopeful that you recall this function from previous examples or possibly from your high school days, all right? When you cube a positive number, obviously you get a positive number. But when you cube a negative number, you get a negative number. And so that's why we're found in this quadrant and this quadrant, right? We square a positive x, we get a positive y. We square a negative x, we get a negative y, all right? And so this is the original function of f of x equals x cubed. Now, in the first translation that we were asked to do, we wanted to move this vertically, we subtracted 1 from x cubed. And so this is what we get. The blue curve represents f of x. The red curve represents g of x. And what we did here is we simply took the entire graph and we moved it downward by 1 spot. All right. Now, it gets a little tougher to see when the lines get a little closer, but if you, damn it, if you look carefully, you can see that that is indeed what happened. All right. And so again, this is a vertical shift or vertical translation down by 1 unit. Okay, a vertical translation down 1 unit. All right, and this is again because we subtracted 1 from the value of f of x, right? F of x is x cubed, g of x is f of x minus 1, or x cubed minus 1. Now, in the second one, we've done 2 things here. First, we've done a vertical shift upward by 1. There it is. Okay. And then we've done a horizontal shift to the left by 2. And so my new graph, shown in red, is raised 1 unit and moved to the left 2 units. God. All right. So in this case, I've got a vertical, and I'm not going to write the whole thing out, but a vertical translation up by 1 and a horizontal translation in this case down, I'm sorry, left by a factor of 2, or by 2 units. All right. So here, where f of x equals x cubed, h of x equals the quantity x plus 2 cubed plus 1. Okay, x plus 2 cubed plus 1. Okay, so that is that summarizes our discussion of translations. All right, and I hope that that's helpful. Now, the second major kind of transformation that we've dealt with, or that we talked about, were reflections. And these are flips across an axis, all right? And so obviously there are 2 axes, and so there are 2 different kinds of flips here, okay? So in this particular case, all right, obviously this is the x, this is the y. If my original line for f of x is this, all right, and so y equals some value f of x, then actually, and I'll leave it blue, and I'll draw the same thing, whoops, here. If I change the value of f of x and I make it negative f of x, all right, well, since f of x equals y, negative f of x equals negative y. So if this is positive y, then negative y is down here. And so what I get is a reflection across the x-axis. All right, and so negative f of x would look like this. On the other hand, if I make the value of x negative, well, this is the positive x, the negative x is over here, and so the reflection of this is going to be f of negative x, all right? And so that's the way that you do reflections, all right? If you change the sign of the entire function, you flip the graph around the x-axis. If you change the sign of the value of x, then you flip the graph around the y-axis, all right? And so that's the way that we look at reflections. Now, so in this case, let's again look at an example. And so this is example number 2. The graph shown on the right-hand side of the screen is the graph of the function f of x equals x to the 4th power. All right. And it's almost parabolic, but it's not quite a parabola. It's not quite smooth, not as smooth as, for example, f of x equals x squared at the bottom. Not as rounded. All right. It's flatter. But in this case, what I'm going to ask you to do is for the next few slides, I'm going to ask you to write an equation for each of the following graphs that represent a transformation of x. And don't be surprised if not only do you see reflections, but you also see translations. We're going to try to get you into this a little bit. All right. And so in this picture, I've got x to the 4th power is f of x. There it is. And I want to know, what did I do to this graph in order to get it to be in this position? All right, well, first and foremost, what did I do to flip it upside down? All right, well, in order to flip it upside down, I took the value h of x, all right, and I made it negative. All right, so instead of x to the 4th power, it's now negative x to the 4th power. All right, and that's what flipped it over. But then I also took it and I moved it upward, so I translated it vertically up by 2 units. And so g of x, in this case, is going to equal negative x to the 4th plus 2. And there's my translation. All right, so in this case, just by looking at the graph, I'm able to actually write the new function here. All right, so g of x in this case is equal to negative x to the 4th plus 2. All right, I flipped it and I moved it up by 2 spaces. All right, I flipped it and I moved it up by 2 spaces. Okay. Now, let's do one more of these, all right? In this case, what we're going to do is have a look at the same graph. So we're starting again with f of x equals x to the 4th power, if it ever changes. And now I've done, again, 2 things, all right? I have flipped it upside down, and so I've made it negative, all right? And so I'll have g of x in this case is going to equal negative x to the 4th. But notice that I've also moved this whole thing over by 1, 2, 3 units. And so my h of x value here is going to equal negative. Now, how do I move 3 units to the right? Well, here I have to change the value of x. And so it's going to be x minus 3 to the 4th power. All right. And so there it is. All right. H of x equals negative the quantity x minus 3 all to the 4th power. All right. So again, I've moved it 3 spaces to the right and I've flipped it over. And so h of x equals negative the quantity x minus 3 to the 4th power. Okay. Example number 3. Here, I want you to compare the graph of each function to the graph of f of x equals the square root of x. All right. So here, all I want you to do is to tell me exactly what we did to this. So no math involved. I'm giving you the equations for g of x, h of x, and k of x. But I want you to look at these and tell me what's going on. So let's look at the first one. All right, g of x equals negative the square root of x. In this case, I'm taking the whole function of f of x and making it negative. All right, and so what does that do? Well, it changes the value of y from a positive to a negative, or from a negative to a positive. All right, but from a positive to a negative. And so that is a flip right around the x-axis. All right. And so if this is the original line, and again, this is one of the 12 basic functions in math, all right? This is the square root relationship, f of x equals the square root of x. Notice there are no negative values. Why? Because you can't take the square root of a negative number, all right? It's undefined. It doesn't exist. Anyway, so for g of x, I was asked to make this negative in this case. So g of x is going to equal negative the square root of x. Now, if I make it negative, what I'm doing is I'm taking the value of y that was positive here, and I'm just going to make it negative. Sorry. And so what's going to happen here? Well, I'm going to reflect this across the x-axis. So this is a reflection across the x-axis. All right, easy peasy, right? All I'm doing is taking every y value that was positive and making it negative. Ta-da, easy peasy. All right, so if f of x equals the square root of x and g of x equals negative the square root of x, I am simply taking the graph and reflecting it across the x-axis. All right. Now, for the next one, h of x was equal to the square root of negative x. So now I'm not really manipulating the value of y, I'm manipulating the value of x before I do the function. And so in this case, every x that's positive, I now make negative. And so what would happen here is what you see in this graph, all right? In this case, the positive x values become negative, the negative x values become positive, and so this is a reflection across the y-axis. All right, now, from today's quiz, if you go back and think about it, all right, what kind of function would this be? When you have a reflection across the y-axis, all right, this is a function. Specifically, it's an even function. All right, that's what a reflection around the y-axis actually is. Okay, now let's look at the function k of x. In this case, I've got k of x equals the square root, the negative the square root of the quantity x plus 2. So I'm doing two things here, all right? What did I do? Well, first of all, obviously, I flipped it around the x-axis. So there's a reflection here, all right, across the x-axis. All right, but in addition, I've added 2 to the value of x. And so what that does is it's a translation to the left by 2 units, all right? And that's what we did right here. We moved it left by 2 units, okay? And so that is the transformation of k of x from f of x. If f of x equals the square root of x, then k of x equals, in this case, negative the square root of the quantity x plus 2. Okay, so that is where I'm going to end this first of 2 videos on graphical transformations. Stay tuned for video number 2, and I hope you learned something.